Alright, let's get right started with your virtual answer key, your interactive answer key to your quiz review to have you all prepared for the quiz coming up here on Monday. Let's get right into it. Looking at number 1, we'll see here we have the answers already written out for you. You want to do two things: listing the pair of congruent angles. That means you just want to go step by step, that when you go through, OS and KN are corresponding sides, so you want to set them up into a proportion, into a ratio, OS over KA. You would also do the next set, SU and AN. They must be in that same ratio. OU and KN finish it up. Those are the corresponding sides in a proportionality statement. The congruent angles being listed, that's the same way we did when we did congruent polygons, congruent shapes. The angles still must be congruent. So O and K are in the first slot, they must be congruent. S and A, U and N must each be congruent. Same thing works here with a quadrilateral, except now we have 4 sets. L to K, O to E, U to N, and S to T, straight across. And then, again, LO to KE, OU to EN, US to NT, and then finally LS to KN, or LS to KT, I'm sorry. So those are the quick, easy ways to begin your quiz on Monday. It shouldn't be any difficulty for you to go right through, list all 4 or 3, however many depending, of congruent angles, and then listing all the proportionalities. So that should be good there. Okay, let us move forward. This we have 3 things we need to find out. Determine if these polygons are similar, and then if so, write a similarity statement, and then find a scale factor from figure A to figure B. So because it's giving us an order will matter for this. So to see if they're similar, we need to look first, are the angles congruent? Well, we have 2 pairs that are congruent. That means the third one has to be as well. So we know that from that we're going to be in good shape. Now we need to see if the sides match up correctly. So we want to look first at the shortest side from each. If we want to go from figure A to figure B, you want to have 12.5 over 5. We now want to, those are the shortest 2. We now want to look at the longest 2, which would be 22.5 over 9, because that's the longest from figure B. And then the last one would be what's left over, 15 over 6. Now, when you simplify these, all 3 of these do reduce down to the same fraction of 5 over 2. You may want to do with these decimals, plug it into a calculator to confirm it. Multiply both the numerator and denominator by 2, and you would get like 25 over 10. That's a little easier to reduce, for example. So, they all reduce to the same number. That is your scale factor, 5 over 2. And because they all reduce to that number, that means yes, they were similar. Now let's see if we can get the similarity statement. We need to have all the matching pieces here. So if we name this first one any way we want, let's just say MLN. That's naming it going from 1 angle mark to 2 to nothing. We want to name the second one the same way, PTO. From 1 angle mark to 2 angle marks to nothing, PTO. So that's how you write your similarity statement. A similarity statement means that 2 things being similar to each other. So it should make sense. Alright, let's take a look now. Number 4. Want to do it the exact same way. Start with the smallest side for each. So we have 9 over 6. We want to set that equal to the largest side for each, which would be 15 and 10. Equals 15 over 10. And then what remains is going to be our middle piece, which is 12 over 8. And again, these should be easy to reduce here. It reduces to a factor of 3 over 2. Again, that's going from figure A to figure B, so it does matter, the order. 3 over 2, that's your scale factor. So yes, again, they are similar because we have that scale factor. Now let's see if we can name them again. If you want to start ABC, we're going from the right angle to the 1 angle mark to the 2. We would have ABC similar to FDE. Triangle ABC similar to triangle FDE. Alright, we're going to keep moving forward. Here we go. 5 through 10 all use this same picture here. First thing we want to do is find a scale factor from MNOP to WXYZ. So go right across MN to WX. MN, we don't know, is A. WX is 16. Well, we can't find a scale factor if we don't know what A is yet. So let's try now NO and XY. NO is 10, xy is 8. So because of that, we can use that to find our scale factor. We know both terms. 10 over 8, though, is not our scale factor. We need to reduce it to 5 over 4. Next problem asks us to find the scale factor going the other way. So instead of 10 to 8 for NO to XY, we want to look the other way around. XY to NO. So it's going to be flipped around. Your answer here is going to be flipped, 4 over 5. So now we need to find values of A, B, and C. Well, already we knew, if we had all these set up, we know that each proportion, so for example, A is the value of Mn. We said A over 16, that's going from MNOP to WXYZ, must equal our ratio, our scale factor from MNOP to WXYZ. So that must equal 5 over 4. If you do the cross multiplication there, you would get that 4 times A equals 5 times 16. 5 times 16 is, excuse me, 5 times 16, well, if you want to do a shortcut, you can see that you're going to get A equals 20 as your final answer, because you would go from 4 to 16 multiplied by 4. 5 would have to also be multiplied by 4. But just to see it the long way around, 5 times 16 is going to give you, it would help if I can do the math correctly, 80. 5 times 16 is 80. Divide both sides by 4. You would get a final answer that A must equal 20. So we'll start there. A equals 20. Now let's find B. Where did B exist? B existed as WZ. So to stay, WZ corresponds with MP. MP, we see up here, is 12. WZ is our value of B. And again, we have the same scale factor, 5 to 4. So we're going to set that up as 5 times B when we do cross multiplying has to equal 48. When we do that division, we're left with B equals 7.2. You could leave this as a decimal, you could put it in a fraction, whatever you prefer to do. So B equals 7.2. Then for the final one, to find C. C corresponds with angle Y. Cool. Because C corresponds with angle Y, Y corresponds in similarity statement with O. And we know O is 95 degrees. So that means that the value of C must also be 95 degrees, just like that. Alright, next step, we need to find the perimeter of WXYZ. Well, already we know 3 sides of it, and we found WZ. We found that B had to be 7.2. If you add all those up, all these sides, 12 plus 8 plus 16 plus 7.2, you'll get your perimeter. That perimeter here is going to be 43.2 when you add them all up. So now we need to find the perimeter of MNOP. Well, we want to remember that perimeter follows the same scale factor. So that scale factor, 5 over 4, 5 to 4, of MNOP to WXYZ will follow the same pattern. We don't know what the perimeter of MNOP is. We do know WXYZ, though, is 43.2. So when we multiply those out, we would have 43.2 times 5 equals 4p. Divide both sides by 4, and we'll get our final answer of 54. And then the final question, what is the ratio of this perimeter, MNOP to WXYZ? Perimeter follows the same scale factor. Again, we're going MNOP to WXYZ, so we want to stick in that same order. Same ratio, same answer as number 5 up here, because it's going in the same order, 5 to 4. Moving forward. Again, multiple steps to do here. Are the triangles similar? If they are, we need to say why, as in give a shortcut, and then we need to write a similarity statement. So number 1. In number 1, we have equilateral triangles here. They're different sizes. If you want to, for simplicity's sake, call one of these, say, a size of 5 and call this one 7, just so you can see it. You want to set these up and see, can we make proportions? If so, you would have, say, 5 would correspond with 7. Right here, this is also 5, and this one down here is also 7. And at the bottom, again, 5 and 7. No matter what values these would take, you're always going to end up with the same proportionality. The answer is yes, they are similar. And it's because of side, side, side. We know all 3 sides have to be the exact same. Now, as for naming which triangles are similar here, really, because there's no difference in the sides, you can name it in any order you want. Here's just one example. You can say that triangle CMT is going to be similar to triangle ASR. You could have said CMT to ARS, CMT to SAR. A couple different ways you could have done that one, so nothing too bad there. Alright, number 12. Number 12, they are not similar. And they are not similar because we cannot use one of our shortcuts. We do not have side, side, side. We're actually only given one side. We are given an angle here. This must be a right angle, but we don't know anything about these two sides here. So because of that, we can't say they're similar because we don't know enough information. We can't do side, 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 or side angle side. 13. We have an angle that we know, so we want to again look, can we do side angle side? And in this case, again, like we had in number 11, we have, if we want to make up numbers, we can call this 5 and 5. Call this number 70 and 70. No matter what you do, these ratios are going to always end up being the same. 5 over 70, 5 over 70, with a congruent included angle. They're both 30 degrees. So because of that, side angle side will allow us to say they are similar, and our similarity statement, triangle MNO, similar to triangle PQR. Number 14, look side angle side again, see if that'll work. We have the congruent right angles. We want to look at the shorter of the two sides, so 3 to 6 between the two, and then the longer of the two sides, 4 to 8. They both reduce to a scale factor of 1/2, so yes, they are, in fact, similar. They are, we got to go in the same order, so if we go A, B, Q, so we went along the shorter side, then the longer side, that must be similar to triangle F, D, M. Continuing forward, number 15. Same sort of idea. We want to look and see. We know that's 9, so does that have to be? We know 6 over here for both of those. For these, we know 3 sides. If anything, it's going to be a side, side, side. The question is it really? When we set them up, the shorter side is going to be 4 to 6 if we're going here from XYZ to ABC. Going that same route, we would have 6 to 9, and again, 6 to 9. They all are going to reduce down to the same fraction, 2 to 3. So because of that, we can say our similarity statement. They are similar with the same scale factor. We'll say triangle ABC is similar to triangle XYZ. Again, we need to make sure everything lines up. So ABC went along one of the longer sides first and then the short side to XYZ, long side the short side. Number 16 down here, we have two sides. They do correspond, that the longer of the sides, 4 over 7.5, will reduce to the same thing as 3 to 6. Well, actually, it doesn't even do that now, does it? So because of that already, we can say no, that they're not going to be similar. Also, there's just not enough information to begin with. We can't do side, side, side. We can't do side angle side. So because of both of those, and the fact that it's not even in the same scale factor, we cannot have a similar triangle here. No similarity. Your reasoning is you can't do side, 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 or side angle side. Alright, the last problem. This is the trickiest one of them all. We want to look at triangle DMP similar to triangle LMN. Now I'm jumping the gun and giving you the similarity statement here just so it's a little easier for us to look at. In those triangles, M is a shared angle. An angle must always be congruent to itself. An angle must always be congruent to itself. Now as for the scale factor, to go from DM to LM, we have DM is 1 tick mark, LM is 2 of those exact same length. So it's got to be twice as long. Our scale factor is 1 to 2. Same here, MP is just 1 of these double tick marks. MN is 2 of those same length. So again, 1 to 2. So we do have a scale factor, we do have a ratio. So we have a side, an angle in the side. So our reasoning is going to be side angle side, angle M congruent to itself because it is a shared angle between the two triangles. Alright. Find the unknown value given each pair of triangles. So for these, we already know what's similar. We can set up our ratios. So we need to know xz. If we want to do AC over xz, we need to use those two combined. AC is 14, xz is x plus 2. We want to set that equal to BC and YZ are corresponding parts that we know both of to find the scale factor, 6 to 14. When we multiply those out, you would have 14 times 14 in the cross multiplying equals 6x plus 12. When you simplify that, you will get that, 184 will equal 6x after you subtracted the 12 over. Divide both sides by 12. If you want to leave in a fraction, it's probably the best here. You would get 92 over 3 as your answer when you divide both sides by 6. In number 19, we want to look the same way. We want to find RS, which corresponds with AB. So AB is 12, RS is 5n minus 1. You also want to look at BC and SQ. They are the other corresponding parts, BC being 15, SQ being 3n. When we cross multiply, you would get 36n would equal, 36n would equal, I'm sorry, I messed this up again. When we set up this proportion, so hopefully you're checking me and seeing that I made a mistake here. AB to SR was 12 over 5n minus 1. SQ had to correspond with AC, so this number up here should be a 4. So 36n should equal 20n minus 4. Subtract the 20n over now, and you will get that 16n would equal a negative 4, and n would equal a negative 1 over 4. So again, make sure all the pieces match up. As you can see, it's very easy to select the wrong one. So keep going. Make sure that you exactly know which ones we're talking about, which sides correspond to which. Let's do one more, see if I can redeem myself from that last one. This is one of the trickier problems. You want to again set up what we know. FG to JK will line up, and GH and KL will line up. So FG, 3x minus 2 over 5x minus 2 is going to have to equal x over 7x. As you do your cross multiplying, it's going to equal 5x squared minus 2x. 16x squared will equal 12x. Divide both sides by x, you get 16x equals 12. Divide both sides by 12. Divide both sides by 16, you need to get x by itself, and you would get x equals 3 over 4. We've done a couple problems like that in class now. Alright, home stretch, last two problems. We need to find the perimeter given this information that we have. So if you want to draw out the triangles to help you see what we have, CDX and GNZ. Fill in the parts that we know. We know that the perimeter here is 48, CX is 14, GZ is 58.8. CX and GZ correspond, so we can set those up in a ratio, 58.8 below 14. And we know that the perimeters also follow that scale factor, 48 over the perimeter of triangle GNZ. Because of that, you would cross multiply. 14 times the perimeter would equal 48 times 58.8. So check your math. After you do cross multiplying, divide by 14, and you would get that this perimeter is going to equal 201.6. This problem should look familiar. This was from your quiz the other day, actually. And now the last problem. Again, draw out the triangle so you can see exactly what to deal with. We know FR is 7. We know that, we know that R is going to be, angle R is going to be congruent to angle K in NKL. So let's see exactly what we know. We knew 7. We knew KL here. This is L down here. KL is going to be 3x plus 2. And K is going to be 5x. And again, these angles are congruent. 7 corresponds to 5x. because FR and NK correspond. We want to set that equal to, we don't know what we know that RA is 4. So RA is 4 over 3x plus 2. Do your cross multiplying. 20x will equal 21x plus 14. If you subtract, you would get a negative x equals 14, which means that x equals negative 14 as your answer. So hopefully those didn't go too badly for you. Hopefully you now know how to find the answer for all these. Have a good rest of your weekend, and hopefully you will be in perfect shape to come in on Monday and rock this test. So that's everything. Have a great weekend, and of course, go Panthers!